Okay, so we are discussing the shape of the distribution. So this is called unimodal distribution when it has just one peak, and this is bimodal when it has two peaks. So two peaks, we have one peak here, one peak here. So this is called bimodal distribution. And when we have more than one peaks, so we have here three peaks. So this type of distribution is called multimodal distribution. So here are examples of symmetric distribution. So this is called bell-shaped distribution. So if you have any distribution which is like this is called bell-shaped distribution. And the normal distribution is bell-shaped distribution. Then this is if the distribution shape of the distribution is like this, triangular. So this is called triangular distribution. And this is called uniform distribution. Actually, this height represents the frequency or relative frequency of the distribution. So this is called uniform distribution. And here they are uniformly distributed because the height for each values are same. So that's why this is called uniform distribution or rectangular distribution. Okay, so based on the shape of the distribution, we can divide, depending on the skewness, we can divide the distribution into type right skewed and left skewed if the distribution are skewed. So if we have a long tail at the right, then it is called right skewed distribution. So if you have a distribution like this is called, we have a long tail right at the right. So that's why this is called right tail distribution or right skewed distribution, or this is also called right tailed distribution. So it has a long tail on the left. So that's why it is called left skewed distribution or left tailed distribution. Okay, so you can also have this type of distribution. This is called reverse Z-shaped distribution. So we have two relative frequency histogram of household size. So this is the relative frequency distribution. So now if you join the midpoint of each bar, then you will get the shape of the distribution. So looking at the shape of the distribution, so is it a symmetric distribution or left is skewed or right is skewed? What do you think?
Right.
Yes, this is right skewed distribution, right? Because it has a long tail at the right. So that's why it is called right skewed distribution. And population and sample data. So what is population data? The values of variable for the entire population. So if we have the values of a variable for the entire population, so you know about the population, right? So if our variable of interest has the entire data, then it is called population data. And the sample data, if we just consider some values from the population, that's when the values of a variable for a sample of the population, a representative part of the population, then that data will be called sample data. So population and sample distributions and distribution of a variable. So what is population distribution and what is sample distribution? So we know about what is sample data and what is population data. So if we have the values for entire population, then that will be called population data. And if we construct the distribution for the entire data or entire population, then that distribution will be called population distribution. So that's mean the distribution of a population data is called the population distribution or the distribution of the variable. And the population distribution is called the distribution of the variable. So for example, if we are interested about the height of all US adults, then all the heights of US adults will be our population data. And if you constructed the distribution for all the heights heights of all US adults, then that distribution will be called the population distribution for that data, or the distribution for the variable height of US adults. So our variable is height of US adults, right? Then that distribution will be called the distribution of all US height of all US adults. So the distribution of a sample that is called a sample distribution. So if we collect a sample from the population and construct the distribution for that sample, for that specific sample, then that distribution will be called sample distribution. So now here we have an example. So we have the population distribution or the distribution of the variable. So here our data is about number of people and corresponding, so number of people is 1 2 3 4 5 6 7, and we have the frequency and relative frequency corresponding to its number. So for 1, the relative frequency is about 0.26 or something. For 2, it is close to, it is 0.33, I guess. So if you look at the distribution of the variable or population distribution, you can see this distribution is, the shape of the distribution is like this, right? So this is the shape of the distribution. So this is right skewed. So now we collected 6 samples. So we collected six samples from the population data. And then we constructed the frequency distribution and the frequency histogram. So we collected 6 samples, and this is the frequency distribution or relative frequency distribution for the first sample. This is for the second one. This is for the third one. This is for the fourth one. This is for the fifth one. This is for the sixth one. So now the question is, which one is the distribution of the variables? So actually, this is actually the distribution of household size. That's mean number of people in each house. That's our variable. So which one is the distribution of the household size? That's mean distribution of the variable. Yes, it is right skewed. You are correct. But my question is, which one is the distribution of our variable? Or which one is the distribution of household size? Anyone? The first one, yes. Because we know that the population distribution is the distribution of the variable or original variable. Now we collected 6 samples. So what do we say about the distribution of the samples? You can also see that most of them are right skewed, right? Because we collected the sample from the right skewed population, right? That's why the distribution of the samples are also right skewed, but it will not always happen. But in that case, all the samples are representative sample of our data. So that's why it happened, because our sample representing our data. But it's not always true that our collected sample will represent our original population. It might not represent our population correctly. In that case, even if you collected the sample from the skewed data, but you can have symmetric distribution for the sample. But if your sample is representative sample of the population, then it should be right skewed. And here you can say that they are not same. The distribution of all samples are not same, but it's kind of similar, right? Because all are right skewed. So that's mean all of them are, most of them are representative samples of our population. Okay, so now the question is, why do we need the sample distribution? Actually, we cannot get the, or we cannot always get the distribution of the population. So in that case, what we can do? because it is not always known the distribution of the population. So in that case, we can collect data, we can collect a sample from the population and construct the distribution for the population, sorry, for the sample. And based on the sample distribution, you can approximate the population distribution, or you can make inference about the population distribution. So if you go to the previous slides, so even if you do not know the distribution of this one, right? Distribution of the population. If you know the distribution of the samples, you have 6 samples and you know all the distributions. So you know the distribution of all samples and all the distributions are right skewed, right? So based on this information, you can make inference about the population distribution. You can also say that the population distribution is also approximately right skewed distribution. So that's why actually we need samples. Samples are really important because the information about the population, most of the time it is unknown. The distribution is unknown, and also the mean, the variances are unknown. So we can just estimate them, or we can make inference about them based on our sample information. Okay, so for a simple random sample, the sample distribution approximate the population distribution. That is the distribution of a variable under consideration. So the larger the sample size, the better the approximation tends to be. So if your sample size is very large, then it will represent the population better. Okay, so that's all about chapter 2. Do you have any question? So what did we learn from chapter 2? So organizing data. So we learned about different type of variable, qualitative variable, quantitative variable, right? Then organizing the data for qualitative variable and the data for quantitative variable. So for the qualitative variable, we used bar chart. Sorry, first we used frequency table, relative frequency table, then bar chart, then pie chart. And for the quantitative data, we also used frequency table distribution, relative frequency distribution, then histogram. Then we used dot plot, stem and leaf plot, and we also used histogram. Yeah. Do you have any question? Okay, so if you do not have any question, then we'll start chapter 3. So the chapter 3 is about, this is descriptive measures or descriptive statistics. So what are the descriptive statistics? Descriptive statistics are mean different type of measures, measures of center, measures of dispersion. So first we'll discuss about the measures of center. So what is the measures of center? The measures of center are, that's mean we will try to find the center of the data set. So there are different type of center. So we consider mean as a center of data set. We also consider median as a center of data set. And we also consider mode as a center of data set. So these are the measures of center. These are the common measures of center. There are also some other type of measures of center, but usually we use these 3: median, mean, median, and mode as a measures of center. So what is the mean? The mean of a data set is the sum of the observations divided by the number of observations. So if you have a data set, for example, if you have a data set like this, 2, 4, 5, 7. So we have a data set of 4 observations, 2, 4, 5, 7. So now we'll calculate the mean of this data set. To calculate the mean, you have to add all the numbers together. So that's mean 2 plus 4 plus 5 plus 7. divided by total number of observations. So how many observations we have here? 1, 2, 3, 4. So divided by 4. So this is the mean of this data set. So 4 plus 2 is 6, 11 plus, so it will be 18 divided by 4. So it will be 4.5. So that's when the arithmetic average of the data set is the mean of the data set. So you'll add them together and divide it by the number of observations. So that is the mean of the data set. So now we'll discuss about the median of a data set. This is also a measures of a center of the data set. So to calculate the median is the actual middle value of the data set. The mean is the average of the data set and median is the middle value of the data set. So to find the middle value of the data set or to find the median, first you need to arrange the data in increasing order. So for example, if you have a data set like this, 2, 7, 3, 5, maybe 1. Okay. The first thing is you will arrange the data in increasing order. You can also do it in decreasing order, but usually we arrange them in increasing order. So then what will be the arrangement? First one is 1, then 2, then 3, then 5, then 7. So if the number of observations is odd, how many numbers we have here? 1, 2, 3, 4, 5. So we have 5 numbers. So this is odd number, right? The number of observation is odd. So then the median is the observation exactly in the middle of the ordered list. So this is our ordered list. Exactly in the middle is 3. So this is our median. So what will happen if the number of observation is not odd? For example, if we have one more number here, suppose we have 6, then what will happen to the median? If you rearrange them again, then it will be 1, 2, 3, 5, 6, 7. So how many values we have exactly in the middle? So how many values do we have exactly in the middle? Anyone? Yes, we have 2 values in the middle, right? So we have 3 and 5 in the middle. So now in this case, the median is the average of these 2 numbers. So if the number of observation is odd, then we'll have just 1 value in the middle. So we have just 3 in the middle. That is the median. But when the number of observations is even, then we'll have 2 values in the middle. Now we have 3 and 5 in the middle. So the median will be the average of these 2 numbers. So the median is, in this case, the median is 3 plus 5 over 2. So this is 4. The median is 4. So that's why if the number of observations is even, then the median is the mean of the 2 middle observations in the ordered list. In both cases, if we let n denote the number of observations, so if n is the number of observations, if n is odd or even, it doesn't matter, the median is at position of n plus 1 divided by 2 in the ordered list. Okay, so in the first case we had 5 numbers, so the median should, the position of the median should be 5 plus 1 divided by 2, so 6 over 2, so 3. So that's mean the third value is the median. So what is the third value? Third value is 3. And in case of second example, we have 6 values. So the position will be then 6 plus 1 divided by 2. That's mean 3.5. So that's mean 3.5th value. So which one is the 3.5th value? This is the third value. This is the fourth value. So the 3.5th value will be in the middle of these 2. So that's mean you have to take the average of these 2, right? Okay, so anyway, simply you can say if the number of observation is odd, then the value exactly in the middle is the median. If the number of observation is even, then you have to take the average of the middle two middle values. Okay. The next one is the mode of a data set. So what is the mode of a data set? For example, if we have a data set like this, 1, 5, 3, 4, 3, 2, 6, 3. We have how many observations we have here? 2, 4, 6, 8. We have 8 observations. So which number has most frequency or largest frequency? Which number has largest frequency? Yes, 3 has the maximum number of occurrences, right? Because 3 occurred here thrice, 3 times. So, or maybe we can consider another number, 2, again 3. So in this case, we have 3 occurs 4 times. So the mode of this data set will be 4. Sorry, mode is 3 because it has the maximum number of frequencies. Okay. So now if we have, let's consider one more data set. Maybe 1, 2, 3, 4, 2, 6, 4, 5. So what is the mode in this case? Anyone? The first number is 4, 1, 2. So what is the mode in this case? 4, 1, 2, 3, 2, 6, 4, 5. Okay. So I got 2 answers. One is none, and some of you say 2 and 4. Yes, actually, this dataset has more than one mode. This is called bimodal. So looking at the shape of the distribution, you already know we can have bimodal distribution, right? So that's mean we can have 2 peaks. So maximum number of frequency means that is the peak of the distribution. So if you have like 2 numbers which has largest frequency, then that's mean you will have actually 2 peak. So that's mean this is actually bimodal. So you have 2 modes here, 2 and 4. Yeah, that's correct. Thank you. Even you can have more than 2 modes, you can have 3 modes. In that case, that distribution will be called multimodal distribution. Okay, so now the question is, all 3 are measures of center. So which one will use as a measure of center? Actually, it will depend on the data set. So the median is not affected by the outlier, but the mean is affected by the outliers. So when you have a data set which has outliers, you cannot use, first I need to actually talk about the outliers. So what is outlier? So for example, if you consider a data set like this, maybe 1, 2, 3, 1, 4, 5, 4, 2, and 67. So which observation doesn't follow the pattern? But which observation is not consistent with the other data? 67, right? Yeah, here 67 is called the outliers. So that's mean this observation actually doesn't follow the pattern of the data set. So this is called the outliers. So if you have outliers or more than one outliers in a data set, in that case, mean is not a good measures of center because mean is highly affected by the outliers. So let's consider one example, then it will be more clear. Okay, so let me erase this one. Uh, so let's consider one example. So 10, 20, 25, 15. So what is the average of these four numbers? $25 plus 15 is 40, or maybe this is also 20. So what is the average of these four numbers? Can anyone tell me what is the average of these four numbers? 20. Okay. So average of this four number is 20. So what is the median? So this is our mean, right? What is the median in this case? $20. Yeah, median is also 20, right? So what is the mode in this case? This is also 20, right? Okay. So now if we have one more observations in our data set, for example, if we have 100, then what is the average? What is the mean in this case? So what is the mean of this data set? Anyone? $36. Anyone else? So what is the average of this data set, current data set? 20, 20, 25, 15, and 100. Okay, so it's 36, right? Yeah, I think it's 36. So what is the median? What is the median of this data set? Median is 25, right? Okay, now if you look at this data set, now you can see the mean in the previous case was 20, now it is 36. So when we do not have this number, these outliers, then 20 actually represents the data set very well, right? So instead of saying this, if we just say the mean of the data is 20, so that's mean we can say like most of the values of the data is around 20, right? This is the center. So that's actually represents the data set very well. But if we said mean is 36 for this data, it doesn't represent 100, right? It is not close to 100. Even it doesn't represent the other numbers, right? Because they are not also close to 36. So all the observations are different from 36. They are not very close to 36, right? So that's mean this mean it doesn't represent the data set very well. But how about the median? You can see this is 25, which is very close to these four numbers, right? That's mean median represents the data set pretty well, though we have outliers in our data set. So that's mean the mean is highly affected by the outliers, but the median is not that much affected by the outliers. So when you have outliers in your data set, it is better to use median as a measures of center, not the mean. Is it clear? Okay, the median is 20. So that's mean is still the median is same, right? It didn't change. Yeah, 15, 20, 20, 2500. Yeah, median is still 20. So that's mean even it didn't affect the median at all. So we have is still the same median, but the mean is 36. So that's mean the mean is affected by the outliers. So that's why when you have outliers in your data set, you shouldn't use the mean as a center of measures. You should use median or mode. The mode is still 20. The mode is still 20 for this data set. So is it clear? Yes, it make the better judgments of center is median and mode when there is no outlier. Yeah, you're right. Okay, thank you. So I'll stop here and see you on Thursday. Okay, so you have one homework.